Good morning to one and all. It gives me immense pleasure to welcome you all to the one-day refresher program on recent advances in physical science and mathematics organized by the Faculty of Science, SCSVMV University, Nadu, Kanchipuram, in association with the National Academy of Sciences, India, Tamil Nadu chapter. Today's program has been specially organized for school students handling physics, chemistry, and mathematics with the objective of sharing recent developments and promoting academic interaction with distinguished experts from IIT Madras. We extend a warm welcome to all the dignitaries, resource persons, faculty members, participants, and the students gathered here this morning. Let us begin this auspicious occasion with a prayer. I request everyone to kindly rise for prayer.
अग्न आयाहि वीतये गृणानो हव्यदातये निहोता सत्सि बर्हिषि ॐ अदर्दरुत् समसृजोः विखानि त्वामर्णावान् बद्बधानाङ्गराम्नाः महान्ताः द्रपर्वतं वियाद्वः सृजाद्धाः अवयद्दान् वान्हान् ओ यिडाः ॐ
Thank you. To formally welcome the gathering, I invite Professor V. Santanam, Head, Department of Chemistry, to deliver the welcome address.
Shri Gurubhyo Namaha. Good morning to all present. First of all, I would like to welcome all the dignitaries on the dais. I would like to welcome Professor M. Ratnakumar Sir, Dean, Engineering and Technology. On behalf of the Faculty of Science and the Organizing Committee, NIC, I would like to welcome you, sir. Next, I would like to welcome Professor G. Shekhar from the Head Department of Chemistry, IIT Madras, who is an eminent scientist. I welcome you, sir. Next, I would like to welcome Professor Dr. Balaji Ramurthy from the Department of Mathematics, IIT Madras. Welcome, sir. Professor Dr. N. Harish Kumar from Department of Physics, IIT Madras. Welcome you, sir. So I take this opportunity to outset, I would like to thank all of them for accepting our invitation from the outreach program cell of our SCSMB. So I would like to welcome Madam Dr. Jayalakshmi from the ECE department, who was instrumental in organizing this kind of workshop. I welcome you, madam. Next, I would like to welcome Professor Venkatesh Chittu sir and other faculty members from all the departments, and very importantly, the participants from the various institutions. So you have accepted our invitation, and you have entrusted that we will be giving very useful information to you. Hope that we will be living up to that expectation. Thank you. Once again, I welcome you all. And last but not least, I would like to welcome Professor Dr. Radhakrishnan, who is the organizing secretary of the program. Thank you.
Thank you, sir, for your warm words of welcome. I now request Professor M. Ratnakumar, Dean, Engineering and Technology, to deliver the facilitation address.
Om Sri Gurubhyo Namaha. Brahma, Guru Vishnu, Gurudevo Meshwarha, Guru Sakshat Paratma, Tasmai Sri Gurave Namaha. So a very good morning to everybody. A warm welcome to all the teachers from fundamental science teachers from outside near Kanchipuram, my dear faculties, all the distinguished guests from IIT, the dais, I all welcome you, sir. Excellent thing, because we teachers, we require always some refreshment or repositioning ourselves, because technology and science particularly is changing the way we are teaching it to the student, delivering to the students, it has to be changed depending upon the what demand exists now, what kind of technology is required, pedagogy activities they used to call like that. So how best we have to deliver this kind of knowledge to the students. So we teachers, that's why we used to conduct this kind of refreshing courses so that they can refresh our mind, focus our attention, learn new things, new pedagogic activities, new things, new technology. And from whom we can learn. We are very fortunate that we have excellent people from from IIT Chennai. We are so fortunate. They're ready to share and that kind of knowledge to us so that we can help our student community. So in that fundamental aspect, our universities arrange this kind of function. Continuously, we are collaborating with the IIT Chennai. A lot of programming we are conducting throughout the year. And this is the first time I think we are conducting for teachers science, particularly fundamental science. The fundamental science very much required, very much required. That is a basic for any technological development. Without fundamental science, just a pure engineering is just an applied part of our science. So such a importance we have to give, and focus should be there on our strengthening our fundamental science subjects. And this is a great opportunity to learn, and we'll try to refresh ourselves and redirect ourselves so that they can share their knowledge, which we can collect it, absorb it, and we can deliver it. Thank you. Oh.
Thank you, sir, for your inspiring address and encouragement. May I now request the Dean, Engineering and Technology, to honor our distinguished resources persons from IIT Madras. Thank you, sir. We shall now proceed to the technical sessions of today's program. Our first technical session is on mathematics. To introduce the resource person, I invite Professor E. Geeta, Assistant Professor of Mathematics, to introduce the speaker.
A very happy morning to one and all present here. It's my absolute honor to introduce our chief guest, Professor Dr. Balaji Ramamurthy, Department of Mathematics, IIT Madras. So his core subject, such interest spans highly complex mathematical domains, and as well as including linear algebra, complementary problems on symmetric cones, and spectral properties of non-negative matrices. Sir has published numerous impactful research papers, more than 100, and he is a globally recognized collaborators all over world. And Professor Balaji is deeply passionate about mathematical education and monitoring, guiding doctoral thesis. So please join me, sir, in extending a warm, resounding welcome to our chief guest, Professor Balaji Ramamurthy. Thank you. Thank you to the participants also. Thank you, sir.
Thank you, ma'am. I now invite Professor Balaji Ramamurthy, IIT Madras, to deliver his lecture.
I don't have anything to lecture here, but I don't know your background, from where you are coming. Just tell, sir, no, from where you are coming. You are, yeah, just school. So where? CBSE school, 12th standard teachers. All of you, huh? Middle school and high school teachers. Okay, you? Middle school teachers, higher secondary school teachers. Okay, okay. So, what subject do you teach, all of you? Maths and science. Okay, right. So, what do you expect from me? So what do you expect me to talk? Do you have any idea? No, if you have any question, you please ask me. Yes. Techniques. Techniques means what? See, for maths we need only
Shock and talk method.
chalk. Yeah, I use only. I am a blackboard teacher only. We have a smart board in our department, but anyway, I have not yet used that one because I am a typical blackboard teacher only. So, blackboard teacher. No, suppose the current goes off, you need not worry. One obvious reason. Okay. Secondly, see, suppose if you have a long board and then suppose proof of the theorem goes around 5 pages, it is easy to have it on one side and then so that suppose I want to, so, but your handwriting should be clear, that is the only problem.
So nowadays I could see students total interest in learning math. Though before and all we had fear of learning math, but now I feel like interest in learning math is decreasing among students. So they have to complete their 10th standard and they don't want to take up math when they go to higher classes. That I could see. So how can we, bring interest? Because we are trying to bring, but even then they have a fear. I don't know, fear or hate.
All over these years, so far, every time also, see, there will be good students, there will be bad students. Don't think that just because when you are teaching only there are many bad students. See, every time we had a good student and then every time we have bad students. So that's not, that doesn't mean that people lack interest in some subject and like that. Even if you take a class, there will be students who will be getting 90 marks. Always there will be, every year there are students who will get 90 marks, who will be getting 80 marks, who will be getting 70 marks, etc. So, anyway, that, yeah, see, everybody cannot be brilliant also. And everybody cannot expect that they should be interested in maths. Why? So, just because you teach, they should get interested or what? No, that's not the... So,
But it is mandatory for them to learn math. No, sir.
mandatory for them to learn math. Yeah, somehow they will pass. Don't worry. Because the world will run anyway. So,
But as you said, you will be using only blackboard because you have to.
no, so far I have used blackboard. Anyway, in the coming years and
How
all,
do
I
you
don't know.
maintain students more get interested till you complete full theorem, sir? Actually, if it is in the school, no, it is like 1 page and 2 pages problem solving. But when it comes to college, it is like 4 to 5 pages. How do you maintain like they'll be getting interested and like they'll be focusing in your class until?
Okay, so see, first of all, 100% a person gets the proof, he cannot understand 100% what I teach. Okay, whatever I'm telling you practically, okay, if I expect that 100% he will be getting it inside the class, that's not possible. Okay, after the class he has to go outside and then take the material and then read and then only you can understand, work out many times. See, I took nearly 2 years to understand one theorem. And if I expect somebody to understand it in some 10 minutes, okay, so that is not possible, okay. Okay, anyway, so I can also tell you something regarding this attention and all. So, see, before starting something, just tell the strategy what you are going to, what is your goal in that particular class, or in that particular the next 10 minutes. Suppose you want to prove something, what will be the strategy? So, how can you attack the problem? Okay, so you can tell that one. Secondly, once you start this one, just don't keep on writing this one. I don't keep on writing this one. Just ask some question also. Suppose I proceed in this way, do you think will you get the answer? So student says yes, then I will ask him how. If he says no, then why do you feel so? So just keeping asking questions like this will entertain their brain. So their focus may not go outside. So this is one small trick that you can always use. And also, see, write clearly on the board. That is very important. Write clearly on the board, step by step. So once the student writes this in his notebook, that will be very useful for him. Even if he goes outside the class, that day if he wants to understand this one, once he takes the notes, and then if he sees this one, then he may recall what I said. So then it will be easy for him than just simply seeing the book and then this one. So that is the so and also teach continuously. Then see, so suppose I teach something today and then I teach something else which is not related this one, and then I come back to day after tomorrow. I come back to on Wednesday. I come back to the things what I taught on Friday. That will confuse. So that's order will always be very useful. Okay. So this is the way how you can do it. But see, sir, most of you are school teachers, sir. So your problems will be difficult. Will be different than my problems. Okay. So maybe you can ask whatever you want.
Sir, what is the basic reason does the children hate math?
Huh? He wants to play. He may be interested in IPL or. So
Not only he or she, sir. Almost most of the children in the class.
No, it's not about hating something. They also hate chemistry. They also hate physics. They also hate your headmaster, your principal. They hate their parents also. Why should they hate only this maths? See, just because they get some low mark, their marks is not good in maths, that doesn't mean that they hate this. Just don't get 10 star like that. If he gets a poor mark, what is the big deal? Say, I also failed in maths in school once. Once I failed that quarterly test. I failed. I remember very well. In one quarterly exam, I failed. Okay, that doesn't mean that that's the end of my thing or not. More important was public exam, right? So that day I did not study, so I failed. So what is the big deal? Memory is the problem, sir. Memory is the problem. Yeah, that is, see, especially that happens in this our this exam, board exam and all. They ask only this textbook problems, right? So whatever problems you do in the class only, they used to ask in the board exam and all. So that you cannot stop this one. They memorize means what you can do. You cannot ask them to not to memorize, right? So if they solve it correctly, then give marks. The solution is correct means they will understand one day. See, when I did 8th standard, I did not understand everything. But when I did 12th standard, I understood the 8th standard problem. Okay.
So
Time will teach
what
them
you are
everything.
trying to
We
say,
cannot
that is
teach
right.
everything. Yeah.
That is right.
Yeah, time will teach everything. Don't worry. So,
Sir, whether maths and science will be bonded till the
of course, yeah. Professor, physics professors are there, chemistry professor. They cannot ignore maths. So without maths, they cannot. Without calculus, they cannot do anything. I don't know whether you know calculus. You teach calculus or not. But without
A
example,
general
in
doubt
study,
only, sir. Just a general doubt.
yeah, without
Till
maths,
the
it's very,
year.
because we all.
Yes, sir. Actually, at what point this integration has happened, sir? Integration between maths and science. At what point, sir?
Integration means what?
A combination or between maths and science.
Maths and science.
Sir?
Compare two things. I need maths, right? Right away, shop onwards, everywhere.
So, basically from there itself it has started. Yes, yes.
Yeah, you buy 2 pencil and 2 pen for 7 rupees. 3 pens and 4 pencil for 14 rupees. Then what is the cost
Maths
of one
along?
pen, 1 pencil? So, anyways, everything starts with.
Maths and science, sir.
Yeah.
Sir, just my doubts only I'm just asking,
No
sir.
problem.
What about that STEM? They are saying no, sir. That STEM syllabus.
No, there is nothing called STEM.
Science,
Once I heard
technology.
from our Chinese president, he told STEM. So for those who have degree in STEM and all, they are welcome to China or like that. STEM means science.
Technology,
STEM means
engineering
science,
and maths, sir.
Technology, engineering and
Maths,
M for maths.
yes, sir.
Yeah.
There in engineering also, technology, everywhere you need calculation, right?
Yes, sir.
So they are used the maths.
Okay.
So nowadays, how do you have something like this smart board or? Yeah, now schools have more facilities, so they have. What do you do in that math lab? Okay. They arrange. Okay.
Pythagoras theorem, midpoint theorem, and all
Okay,
we have materials to teach.
Do you have any labs like that, sir, in college level?
No. For us, once you go to higher level, for maths, there's nothing like, called lab and all. There is nothing, only pen, pencil, and then everything is. Okay, one thing I can tell you. Do you teach sin theta, cos theta in your this one? How many of
yes.
you teach sin theta, cos theta? 10th standard it will come, right? What is the definition of sin theta?
Opposite side by hypotenuse.
Opposite by hypotenuse. That is the sin theta.
Yes.
But once you go to higher level, that is not the definition of sin theta. Not continuous and all. That is something to see a serious definition. So that's somewhat complicated. But it's very, very rigorous, this one. There are no triangle, no pictures for us. Only equation, only this one. So there is nothing called opposite side. There is nothing called hypotenuse. There is no. So, but the identities and all will hold. Cos square x plus sin square x will be 1. All these identities will hold. So for us, sin x is a function. That's all. And then how to define that function. So this is the. So my answer is there is nothing called a lab for us. In our department there is a lab, but lab is where we the computers there, systems. So that we call it as lab. So other than that, we only. I think in chemistry and physics they have lab. For us, no lab.
Sir, as you said, no, when you go to college level, it's totally different what they study in school days. So we are now teaching the children integral calculus and differential everything in 11 and 12. Where the children.
Okay, one thing you can ask your question. I'm not telling you different. These are all basics. Basics. Just see once. Suppose you observe something, and then you take something notes, and then what you do is you just take something notes. But that's not the formal thing here. How will you develop a theory means from those things only we develop. Okay, so that's why I told you sin square x plus cos square x equal to 1. Suppose you define sin x and cos x, and if I show that sin square x plus cos square x is 2, then there is no meaning what you have done in the school. Okay, everything will coincide. But these are all only small, basic things only. How, suppose you want to formalize everything, then it's a different thing there. There is no pictures, there are no pictures, there are no, what can I say? There are, this only purely abstract things there. In Max means abstractness, so that's a, huh? Where the current research is happening. Ah. There's nothing called one advancement or like that. As advancement in every problem, there are various problems there. So what is, no, you are teaching in, you are teaching here. Okay. So advancement means not in one area or like that. Mathematics means there are several topics. Okay. There are several topics are there. See, for example, in one thing I can tell you, see, suppose if you take something called linear algebra means, just imagine that you have 2x plus 3y equal to 1, 4x plus 5y equal to 6. You want to solve x and y. How do you do it? First equation multiply by 2 and then subtract and then you eliminate x and then you get y and then you take x. Okay, this is the small thing, okay, only two variables are there. Suppose I have 1000 variables and then I have 1000 equations. Suppose I have 1 crore variables, 1 crore equation. How will you solve? So, my life is not enough for me to solve. Okay, it will take 1000 years to solve this one. But how will you solve it in a week? Okay. So for that and all, how will you develop a theory? How will you develop this algorithm? Okay. So suppose, see, of course, a human being, man cannot solve this one. You need only machine. But inside the machine, suppose you want to solve it, you should have a technique. How do you solve this one? Not one by one, x, y, x1, not like that. So for that, how will you attack this one? So like that, in that area, how will you do this one? That is one. That is one thing. Okay, like this, there are many. There are many things. This is only something linear. Suppose you go to non-linear, it is even more difficult. So, and there are very theoretical things. See, suppose x power n plus y power n equal to z power n. No three positive numbers x, y, z will satisfy for any natural number. That is called Fermat's last theorem. Maybe so. This Fermat's last theorem was solved in maybe some 17 or 18 years back by a person. But what that person did was he sacrificed his life. He went into a room and then he sat with that for so many years. He himself is a very brilliant person. So, and he came up with a proof. So, this is one advancement I can say. There are many advancements which are happening. So, how will you generate a prime number? Largest prime number, which is used in all these ATM machines, cryptography. So, what is the largest prime number known? Nobody knows. Whatever comes to their mind, they will tell. Whatever up to their knowledge only they can tell. But number of primes is infinite. That's a theorem. It is a theorem proved by somebody called Euclid. He showed that very simple argument. Within 2 lines he proved. There are infinitely many primes. But what is the largest prime that is known in this world? People are working in that. So if somebody says there is a largest, then another person's ego will hurt and then he will take up and then in another 2 years he will come up with the largest prime. So anyway, these are all some of the things. Not in one area. Advancement in everything. Whatever see, I will also say, suppose Professor Shekhar is doing chemistry. He may work in lab and he may come up with a problem there. Then he will ask how to solve this one. Is there any method to solve? That is also an advancement. So there is nothing called one advancement or like that. So and yeah. Yeah. professors have slides, they will show you something, so, but I don't have this.
Sir, all teachers.
See, I'm a, see, to tell practically, you may be a good teacher than me.
No, no,
See, my, yes, I have failed plenty of people. So, but, huh?
Students are that much over the screening time, so they are listening and all, it has been reduced like that. So as you all are more experienced than us, so any special guidelines for us to make our children to be better? A guide? Maybe for more, to avoid them from the screen seeing or anything.
To avoid a screen.
Screen
That
time,
you
sir,
cannot do
screen
now.
time.
Now, see, now the world has changed. You ask them to switch off the mobile, definitely they will not. So that's not going to happen in this one. So even in our class also, many people watch many other things. So we are not controlling. But anyway, our system is different. But to school level, you cannot control this one. So maybe what only the parents have to tell. Don't use. Their parents should not give mobile to them. So you ask your principal that school our students should not use mobile.
We in our venue we are not using, sir, but still after going to house they are again going with the screen time. No, that we face as a problem in schools. Their knowledge is declining or what the.
Suppose they don't use the mobile also, there is a problem nowadays. They see they have to cope up with other people, right? So
People in
see,
this.
mobile teaches you everything in the world. Not only, so why do you think that it's a bad only? See, suppose you are teaching some topic, maybe in, you tell one topic what you teach. Arithmetic mean, geometric mean. Arithmetic mean, geometric mean. Suppose they type in the YouTube, arithmetic mean, geometric mean. Excellent videos are there.
So we as
How the children, why do you want to, the child to prevent from using this
so we as teachers should teach them to take only the good things that has been available in the mobile.
Good and bad. They have to take the good things only.
Okay, sir.
Don't worry anyway, see, these are all, world is changing. Today mobile has come, tomorrow what is going to come also you don't know. Then that day you will say that mobile.
Or correct, sir.
Today, then that day you will say that mobile itself is fine.
Better.
So now so AI has come, AI, artificial intelligence. Just you type whatever you want, it will give you the answer. All school, all these problems, whatever you have in these textbooks, no, if you type their question, it will give you the answer. Huh? It gives the answers. So, but anyway, in exams, you cannot take this one.
Sir, we have a doubt, sir, whether AI will replace the teachers, sir. Whether AI can replace teachers, maximum teachers have the doubts, sir.
See, suppose whatever you have taught in the class, one problem, suppose you have taught problem A. Student goes to the child goes to his home and then he types the problem A, whatever you have taught in the class, it will give the answer. Teach me this problem means it will give you all the steps. Already it is giving. So already replaced. So why it is
About
going to
in-mask.
replace or not? But only thing is that there are this AI still makes some mistakes there. Not completely perfect. In fact, I myself found even calculating determinant also something it gives you 3 by 3 determinant. How many of you have taught determinants? Determinant you have not taught. Integration. Integration you have to talk. In integration also it makes some mistakes. This AI differentiation. Some mistakes it makes. But anyway, it's. But in the coming years, I think they will rectify it. So otherwise, they have to buy this a paid version or like that. So, not only it solves the school problems, advanced problems also it solves. So even papers also it writes. PhD also PhD also will come from this. So it is see those who don't have PhD degree, it is what I can say, it's a guide or like that. So, huh? Yeah, yeah. So, okay. Any other thing that you want to ask? Okay, then continue.
Thank you very much, sir, for the insightful and thought-provoking lecture. We now move on to the physics session. I introduce the resource person. I invite Professor V. Akshay Siva, Assistant Professor of Physics, to introduce the speaker.
So let me welcome Professor N. Harish Kumar, who is a Senior Professor in the Department of Physics, IIT Madras. So he has been working in IIT Madras from last 20 years. And his research expertise in novel magnetic materials and superconductivity, instrumentation, automation, and magnetoelectronics. So he will enlighten us with our conversation. So, sir, I welcome you. So let's hear from Professor.
Thank you, sir. I now invite Professor Dr. N. Harish Kumar, IIT Madras, to deliver his lecture.
Yeah, nice to meet you all and tell you something about the various developments that are happening in the field of physics. And physics, as it has close links with almost all the fields of technology, the application, applied side, and even it has its impact on medical science, all the diagnostic tools, you go to a hospital everywhere. So that's why it impacts directly the society. So I will, so sorry, this one, just
That's why when you remove it, you have to escape that.
Mouse pad.
Pad is, that's why I'm having my mouse. Yeah.
Close mouse in the
That mouse you just take it. And I can just operate from here. I'll just say like this and then say no. That's it. Once in a while it will pop up, that's all.
That's no need directly you can press.
Directly I can do that. But other Verma? Then I'll manage. Yeah, after that I can. Yeah, it will come. Fine. Okay, so I will just straight get into the topic. I just named it as Exciting World of Physics. It is exciting to me. I hope it is exciting to you as well. Okay, I am able to convince you. That's fine. Yeah. So first, we should have, before we try to excite our students, we should have a clear understanding of what physics is. Okay. Well, it borders closely with philosophy. Before 1900, there was no name called physics. It was natural philosophy. What Newton had was degree in natural philosophy. There was not even a distinction between other things like maths, physics, etc. That's why you will say try pass in maths with everything. And he has contributed to maths, physics, right? Calculus also he has contributed, numerical analysis, and physics also. Physics also not in one particular topic. Gravity, thermal physics, acoustics, optics. So there were no such clear divisions those days. So he has contributed in many ways. Okay. So I have put 3 pictures. The reason why I just put three photographs will come up. I regard Galileo as the father of modern science because from there the philosophy branched off, science branched off, I would say, from philosophy. Same questions. Philosophers also will ask the question, who you are, what I am, etc. Here also we are asking that question. Finally the atom, no, what is this made up of? What is there inside? If I break this, what will be there? Like that. Okay, that question finally led to this atomistic model. And even that can you break? Then particles are there. So that's how that whole thing evolved from there. The only difference is from Galileo's time, he emphasized that you say whatever you want, but convince me by experiment. So experimentation became an essential thing to confirm something which was absent in philosophy. There it was through logical reasoning. Okay, you try to convince so many arguments. But here you settle the issue by an experimental proof. That's where the science differs. Okay. In fact, there was a famous mathematician, Bertrand Russell, he is also a philosopher. He said that when philosophical answers are found to philosophical questions, it is science, he says. I modify it. When partial answers are found to philosophical questions, it becomes science. Because I can't say that we have got complete answer or something like this. Okay? That's why research never stops. It keeps on going. Okay? So the word itself, say nature, physics, Greek word nature, natural philosophy, it was the earlier name. That is, whatever you see, any phenomena that you observe or anything that you observe, you try to explain. You pose this question, why, how, when, and try to find answers. And that, whatever your answer you are trying to get, with a combination of that experiment, the results you get from experiment, based on which you give an interpretation, that interpretation part of it is the theory, and this is the practical. So you have to combine these two, that becomes a subject, physics, like this. That's why it's not confined to this or something. You cover several orders of mass scale, scale, energy scale like this. Physics will talk about what is happening in the space between planets, massive objects. At the same time about nano scale or subatomic particle which you can't even see. That also physics deals with. Energy, we will say milli-electron volt, micro-electron volt, and we will also talk about giga-electron volt, mega-electron volt like this. That also it takes care. Length scale, you can't even see. And then you will say nanometer, angstrom units, picometer, like that. But you also deal with, you don't even talk in terms of meters, you talk light years. If you go with the speed of light, it will take 1 year to reach that place. The nearest, closest star, other than the sun, the next thing if you take, Proxima Centauri, we say 4.2 light years from our solar system, like this. So it tries to cover so much, that's also the complication it is having. That's why we have so many parts in this. Okay? Then I would say, so that's why Galileo started with this heliocentric model. Before that it was thought that it is Earth, everything is revolving around that. Even as late as 1990 or so, the church did not accept this. Pope said Galileo is wrong in 1990. They didn't, because it will go against their thing like this. But Galileo said it is sun at the center and the planets are moving around this thing. Because we maybe tend to think, no, wherever I am living should be the prime one. So Earth should be at the center. That may be the geocentric one. And then Kepler. Look at this. They're all in 1564, 1642. At that time they were thinking. And Galileo even invented the telescope. Right? He made a first telescope. Made it. So astronomer, etc. So you can't really put in this category or that category. Many of the experiments which Galileo did later gave inputs to Newton to formulate those gravitational laws. He gave his laws of this thing, motion, based on the experiments which Galileo has done on inclined plane, like this. Kepler, just by that observation with the telescope and everything, he was telling about the planetary motion. There was no satellite or any this thing to view, etc. He's just making a systematic observation. That is key to any science. Keen observation. Everybody looks at the sky. Everybody will say rainbow is looking nice. But the physicist starts thinking which color is at the bottom, which color is next. Then they come with thing, there is a primary rainbow, there is a secondary rainbow, like that, and gives an explanation why it is happening. There is a water droplets in which suffers a reflection and a refraction, one reflection or two reflection, like that. That is physics. Okay? Then of course I would say Newton's is a starting point for the physics. Galileo is still a father figure kind of a thing. Then from the formal structure of physics is starting with that Newton's laws, which we are now calling as classical mechanics. There are other forms of classical mechanics also, and higher level we'll say Lagrangian, Hamiltonian, etc. Then it is not that everything has come in the modern this thing. From the ancient time onwards, the reason I put this is, many times we may let to think that everything happened in the Western world. It can't be. You say that the civilization, Mohenjo-daro, Harappa, etc., it is not in the Western world. How civilization evolves? Only if they know how to calculate, how to make things, etc. Obviously, it has to be in this region only, this thing. So you see that grammar, why did I leave here? Because it is kind of a structuring a language in a particular way. You put some rules and regulation, right? Instead of simply in a colloquial form, you are trying to bring some order into that thing. Then there are so many mathematicians, astronomers, even medicine and surgery, Shushruta. My brother is a plastic surgeon. He said in this book he has read about Shushruta. He used to just, he didn't have any anesthetic thing, maybe country liquor he gave, I don't know. And then he was joining the arms, in battlefield people's hand will be chopped. He was joining that, okay, long ago. So that happened in this country only, okay. So I just randomly picked, there are so many others are there. I may not be able to cover everybody. The J.C. Bose, this is the modern. Earlier I showed the old era. Now it's a modern era, at least from 1850s, etc. I see J.C. Bose time. J.C. Bose, okay, you can call him a physics man, you can call him a botany biology also. Because first, wireless transmitters, receivers, okay, he developed, but only thing is he didn't believe in taking patent. Marconi got the Nobel Prize, but much before he was using his things. And you can understand in 1885 what will be the facility available to him. So what he did is he wanted to demonstrate his microwave transmitter receiver. So he went to he was faculty in the Presidency College, Calcutta. He went to the head of the department room, put a small amount of explosive on his table. He went to the faculty room and triggered it. That's how he demonstrated that he can remotely, he can trigger it. Okay? And he was using one crystal for detection, galena, or naturally occurring mineral. Later, people were using in radar detection in the Second World War, the galena crystals, which he has used. And if you go to the website of Bose Institute, Calcutta, which he established that time, you will see some pictures. He used twisted jute bundle for polarizing microwaves, producing microwave carbon arc. So like that with available material, he has done that. Okay? Ramanujan, of course we are proud that he belongs to this state. Mathematician, okay, who has made significant contributions, so that's why we still talk about it, even today. That's the thing. C.V. Raman, of course, as on today, the one and only Indian Science Nobel laureate means that the person who took the degree as an Indian, took the award as an Indian, is C.V. Raman. He studied in the Presidency College, Chennai. Okay? He doesn't even hold a PhD degree. It's not required, of course. Then, but many universities gave him honorary doctorate degrees, okay, for his achievement. Meghnad Saha, he has done Saha ionization equations and all in cosmic rays. So people in this astrophysics, cosmic rays, they know about the thing. S.N. Bose, Satyendranath Bose, some years back they were saying, God's particle found, Higgs boson, Higgs boson. From where that name boson comes? Bose, Satyendranath Bose. We classify fundamental particles into those who obey one particular type of a statistical. You have a large collection, you apply statistics, average behavior. So Fermi-Dirac statistics, Bose-Einstein statistics, like photon. Okay? Those which obey his statistical distribution is called bosons. Okay? So that is by S.N. Bose. He didn't get any Nobel Prize, etc. But that doesn't matter. Okay? You shouldn't think that only if somebody gets a Nobel Prize is many significant contributions they even without even getting big names or mention, etc. And incidentally, the C.V. Raman, Meghnad Saha, S.N. Bose all worked at the same time in Presidency College, Calcutta, appointed by the then Vice Chancellor, Asutosh Mukherjee. He's a well-known man. Okay? He was the one who brought them all into Calcutta University Presidency College. All of them made significant contribution. Okay? Then Shanti Swarup Bhattacharya, a colloidal chemist. You might have heard about this Council of Scientific and CSIR labs, Council of Scientific and Industrial Research. He was the first director of industrial research. Okay? Well known for his work on colloidal chemistry. Homi Bhabha, father of our atomic program, all the atomic establishments established by him. Even he was the one initially put us in charge for the Space Commission also. Vikram Sarabhai took over. Okay? Chandrasekhar, nephew of C.V. Raman, got the Nobel Prize, but as an American, okay, for his work, Birth and Death of Stars. Okay? There is a Chandrasekhar limit, okay, below which it will not collapse, the star will collapse like this. This is all by just calculation. He is a theoretician, I would say pen and paper. But he predicts something, later people verified and found it to be true. Vikram Sarabhai, you know what, today whatever advancement we are seeing in space or even the nuclear science, you owe to Bhabha and Sarabhai. Great planners, they did so many things. Of course, there was other thing. After Sarabhai, he passed away untimely. Both of them passed away in their 50s, 59. Unfortunately, he died in an air crash, they say. And Sarabhai, mysterious death in a hotel room. And 52 years only, but they achieved within that period whatever they can do, something to the country. Okay? And then Satish Dhawan took over and he also did good things. I didn't put him here. Hargobind Khurana, way back in 1968, he got his Nobel Prize for philosophy, the Nobel Prize in physiology and medicine. Nobel Prize is awarded in 5 subjects. Now, later they introduce economics, this thing. We have some Indian name in everything. Okay, they might not have won it as an Indian, but all the 6 we have Indians, Indian people. Okay, Hargobind Khurana got it for his work in genetics. Okay, basically he's a biochemist. So from where he has given proteins he has investigated. And Professor G.N. Ramachandran, many biotechnology people will be knowing about him. Okay, so he gave what is called a triple helical structure. His structural biology, this thing from physics man, actually student of C.V. Raman, and he was also the first head of the department of physics in Madras University. They contacted C.V. Raman and asked him to come. He said, I have my own institute, I will send my best student. Then GNR came, we are like this. His name was nominated for several times to Nobel Prize, though he didn't get it. But he has done important contributions. Because of today, molecular biophysics, all these things we are talking about. Then that last man is Vainu Babu. There is an observatory in Kavalur, a big telescope. Okay, he was the first head of that thing. There are some comets named after him. Comet is named as Babu Comet. Okay, his work is in astrophysics. Like that, there are so many. Of course, I only put some limited number in this thing. Okay, so don't think that there is no contribution from the Indian side. We do have it. Okay. Then so many discoveries. I can't cover everything, so I just listed something. I thought, let me tell some important things that has happened in the last 4 decades. Laser cooling. You have heard about laser cutting things. Okay, laser surgery, but people use laser for cooling also. Laser consists of thing, but it's optics, right? Photon, optical wave. The energy packets we call as photon, which carries a momentum. So if you make the particles sit quiet, temperature will fall. If you take a material, you heat it, what will happen to that solid material? The atoms inside, they vibrate. They have only that degree of freedom. They start more and more vibrating violently like this. You make them quiet, temperature should fall. That's the principle. You cool by some other method to some level, already they are moving very sluggishly. Then use crossed beams of laser and arrest them. Temperature will fall. That is laser cooling. Okay? And they create a new form called Bose-Einstein condensate. Using Bose-Einstein, you will see that it goes into a new low energy state called a ground state. High temperature superconductivity, late 1986 discovered. I joined for PhD in 1988. Obviously, I also worked in high temperature superconductors. My PhD topic was high temperature superconductors, etc. Before that, if you want to study a superconductor, you need liquid helium. But once this high temperature superconductor came, you no longer require liquid helium. Liquid nitrogen is enough, which is much, much cheaper than helium. Helium is, you don't have it, you have to supply the helium gas. Nitrogen, we have a plant in our department, 40 liters per hour. It just takes the nitrogen from the atmosphere. More than 70% you are having. So it will just purify, compress, and take it like this. So we are producing at the rate of 40 liters per hour and supplying this thing. And high temperature superconductor, and this was also found in something which you normally don't expect. An oxide, which is a ceramic material, was first turned metallic and then it became superconducting. Okay? So that's the thing. Then nowadays there is more talk of these things, spintronics, magnetoelectronics, magnetoresistance. See, electrical property when you are talking about, you will apply an electric field to a material or a voltage, potential difference, then only a current flows. And the material will offer some resistance. If the material offers no resistance, it's zero, I call it a superconductor. Okay? But as the current flows, the electrons not only have a charge, but they also have a spin, which I can control by applying a magnetic field. So, the electrical current can be controlled by a magnetic field. So, that gave rise to this idea of spintronics, because the electronics is almost reaching a dead end, where you can't do any more it went with a single agenda, miniaturize. That's over almost. So, there is no further miniaturization. VLSI is VLSI, that's all. So, how do you improve? Okay, for the same capacity, that thing, I can have some information carried by charge, some information by the spin. Quantum mechanics tells electron has a spin in addition to the charge. So I can use that for information. So that is the way it has come. Then giant magnetocaloric effect. Normally you would have seen our household refrigerators, etc., compressor based, right? You compress a gas and then expand, etc. That's how you are getting cooling. But this can also be achieved by taking a magnetic material, magnetize under isothermal condition. It will get heated up, take away the heat, then go to an adiabatic condition, demagnetize, cools. It takes its own internal energy to cool. So people are trying to see whether we can have refrigerator based on this, where there is no need for this compressor, etc. You don't have to deplete your ozone layer by freon. So magnetic refrigeration. Then nano people started talking. Anything can be small particle, you can make it. I would say even your Maida particle, if you see, it will be nano. So the main idea was like, what will happen if the particle size keeps on reducing, say 10 nanometer and below. Okay, the particles are small. Electron size is very small. Okay, but that is not the issue. The electrons do have a wave motion, right? They form standing waves within the atom also. That wave will have a wavelength. Now you are trying to confine them. Their behavior will change. So that gives rise to this idea of this nanoscience and technology, where even the band gaps between valence and conduction band, etc., they can be, that is semiconductors and all, you will see there is a valence metal everywhere. There is a valence band, means the outermost up to orbital, until they become free. If they are free, then I will say conduction band like this. So that band gap can be changed. You can get normally metals like gold, silver. There is no band gap, we will say. But the same thing, when it becomes nano, a band gap will be there. It will absorb some color. You will get color gold. You can get color silver. Whether you want it or not is a different thing. But you can change their color, you can change their property. Surface, photonics, of course, if you can use, the moment we know that light not only has this wave characteristics, but it can also show its particle aspects. From phenomena called photoelectric effect, you shower light on some surface, metallic surface, electrons come. It's called photoelectric effect. Einstein gave the theory for that. So the moment you know that it is having this particle aspect also, then why don't you use it like electrons for communication devices? So that is called photonics, okay? Where you control not electrons, but photons. So photonics there. Surface science, graphene. Graphite is a material, then it is a layered structure. There will be 6 carbon, like this, and then layers will be there. But the bond between the layers is very weak. Van der Waals bond, it is easy to remove one. So somebody succeeded just by using a scotch tape. He was just doing like this, and finally accidentally one layer came. They got the Nobel Prize also. Okay. Then nowadays they talk about 2D material, two-dimensional materials. So that has come as a separate science now, this thing. Particle physics. That's why I was telling God's particle, I said Higgs boson. So they wanted to, somebody put a model called the standard model. These are the fundamental particles using which matter is constituted, like this. So you have to tell from where charge came, from mass where came, from where mass came, like this. So Higgs boson, we said from their mass, like this. In that model, only this particle was not yet found, not discovered. Then they set out to discover that. For that, the energy required was more. So they built a huge accelerator, international effort. And then finally they said, we discovered it. Okay. So that's the thing. Particle physics, that's advancement. Non-conventional energy sources. Energy is always our continuous requirement. No, any amount of power, we still consume that thing. So instead of just relying on hydroelectric power, if you are relying on, it will fail in summer. Even if you have thermal power, coal, most of the coal, not only in the country, we import heavily. Okay, that may be shortage may be there. So instead of relying on any one such thing, now the idea is to tap the energy as wherever it is possible. Wind, windmills, sunlight is there, solar cell, the photoelectric effect. So you can exploit that one. Even the waves, ocean waves, so like that, biomass energy, biofuel, so many things are being done. Now they talk about quantum computer, etc., for which they have to use the spin of the electron, etc. Qubits, they say. Superconductors are being used now. Okay, of course you have to cool them. Okay, space probes. Instead of just looking at the telescope here, put the telescope in the spacecraft and then there was a Hubble telescope launched some time back, using which they study not only the outer space, beyond your solar system, etc., and try to get LIGO detector. Einstein theory, Einstein did so many revolutionary stuff, he said, but then proving that became a challenging thing. He said, just like you are saying, see, two charges interact with each other. They don't have to touch each other. Two magnets are at distance, action at a distance. They still influence, right? And we say there's a field doing that. So, and we also say the energy of the electromagnetic field travels, propagates in space as electromagnetic wave. Same way he said there is a gravity wave. The gravitational field is there and there's a gravity wave. So people set out to detect so many years, almost a century effort. Finally they say that they found it with this LIGO detector. This is using a thing called Michelson interferometer, and then they will make a huge one separated at kilometers distance, and then they say now they are able to detect the gravity waves, and using which they are predicting, oh, some supernova has exploded there, something has happened like this. They are predicting like this. So you see, so many things are happening in different directions like this, because physics is trying to address each and everything like this. And what is the link between that thing? But he was asking, how will you generate that interest? Whatever you may get later on. See, for example, that superconductor I was telling is just a material losing its resistance, zero. It will also repulse a magnetic field. We call it as a diamagnet. In the laboratory, I'm just seeing it like this. But the same thing is being used for moving it without friction. Maglev train, they will say. IIT Madras has put up one 400-meter track called Hyperloop, where they levitate like this and they create a vacuum also in that low pressure, that chamber. Train moves fast from here to Bangalore, maybe 2 minutes. Okay, so all these are being tried. So the connection between science and technology is new phenomena are discovered in science. How to exploit it for a useful application, that is technology. In a large scale application, engineering. So all these are connected, okay? And they can also give back to science, because we will get sophisticated instruments to study further, okay? So they do have this connection. Now I just pictorially, I just show something, then int. This is the Large Hadron. I was saying the Higgs boson discovered this thing. Underground, between Switzerland and France, the border, 27 kilometers, there is a tunnel, a track. Here, just particles, two protons will come and collide and smash. You analyze the fragments and keep seeing whether any new particle has come. You can't put a balance to measure the weight and this thing. But Einstein's equation E equal to mc squared, that will be used. They will measure the energy and then from there they will infer. Okay? And then finally they said, well, we have found the Higgs boson, like this. Okay? And to do this, they have to do so many. They have to evacuate this thing. Every 100-meter one superconducting magnet will be there to bend the beam. So much of technology also involved in that, this thing. This is the inside cross section. Of course, these things will be complicated. This is the model in which this last fellow, that's the one which they have not detected before that. So after this LHC, they said, okay, we have detected that Higgs boson. This model is complete. We have verified this. This is a fundamental particle, but then people don't give up, no? They say, after that what? Beyond the standard model. And now they keep proceeding. That's why I said research never stops. Another effort that is going on in France is, basically, we create, nuclear reactors are usually fission reactor, where a heavy nuclei is broken up into smaller. But when two smaller nuclei combines, helium is produced, energy is also released. That's the energy of the sun, right? Continuously fusion is going on. And the fusion process, you will get more energy. But as on today, there is no sustained chain, this fusion reaction possible from which you can take the energy out. So there is an effort going on in France, in a place called ITER program it is called. India is also a partner. Each partner country gives 10% technology, and then once it is successful, you will get the remaining 90%. You can set it up at your own place, the fusion reactor. Okay, by 2030, it should be operational. That is the expectation. This thing. This is a train I was telling, maglev train in Japan, a city of Tokyo and Yamanashi, 260 kilometers. They are trying to have a test track like this, where the magnet will be in the track, superconducting coil will be there in the wheel side of the train. It's lifted basically because of this diamagnetic effect. So there's a air cushion. Of course, if a friction is removed, it's a necessary evil. So to propel, they will have coil in the front as well as coil in the track. Then you have north, south, keep pulling the train. This goes at 600 kilometers per hour. Okay. Ferrofluids. Basically, ordinarily all magnetic materials are solids, but you can powder the magnetic particle as a nanoparticle. You can disperse them into a medium, a liquid medium, and then you get what is called a ferrofluid. You form a stable colloidal solution so that the particle should not precipitate out. Then this liquid combines the property of a magnet as well as of a liquid. You can change its viscosity by applying a magnetic field. And this finds application. Earlier engineering application only was known. Now more and more in biomedical field. For example, if you have a tumor, you inject in that region and then subject to an alternating magnetic field, it will get heated up because of hysteresis. And if the temperature rises to 42 degrees, that cells will die. So without affecting the other region, which happens in the radiation thing, you can avoid that and do that. It's called hyperthermia. MRI in hospitals, you can improve contrast using this. Okay, like that, so many applications are there. For want of time, I am not going details. Liquid crystals. You have to thank this material for reducing the size of the TV. Otherwise, earlier TV used to be like this, because even though electronics was becoming smaller and smaller, picture tube was not reducing in size. As long as it was cathode ray based, the cathode ray tube, CRT tube, where you need to produce electron, you have to accelerate over a distance and then a fluorescent screen, all this. But the moment liquid crystals were discovered, it's no longer necessary. So you just, they will allow light to pass through in only one direction. Molecules will be aligned like this. If you pass light parallel to that, it will go. Perpendicular, it won't go. So thereby you can create contrast. That's how these liquid crystal displays came. So many of this, all these are, and then seeing this, they went for LED based, etc. But the first major thing came from liquid crystals, where it basically reduced that screens, that picture tube, from that to a thin screen like this. So that's a major. Shape memory alloys. This is a kind of materials, you can heat it, it becomes straight. It was initially having this shape, right? Then became straight. When it cools, it will come back to that shape. Okay. So people are thinking, see the aeroplane, when it is at ground, maybe Chennai right now 30 degrees centigrade, it goes to elevated place, that will be minus 42. Every day it goes up and comes. There will be fatigue, material can crack out, etc. If you can have such material which can adjust itself, then the problem can be solved. Okay. Again, things in the science which are discovered in the lab will become a big application later. So that's the thing. This is all about refrigeration. I leave it. Laser. Once upon a time, laser means red laser, ruby laser, we will say. Then came this green, etc. Now any color is possible. Blue was a challenging stuff, but later that also was found. Now you have all colors and white you can have, like this. Okay. This already I mentioned. I am just showing pictures only. Photonic circuits are there. These are all whatever I already discussed. I have just given. They are not just in paper. They are reality also. So that is what I am just showing. And producing energy is one thing, storing also is important. So of course you have batteries, fuel cells they will say. It has to breathe, just like how we are working. What is the energy for us? So the breathing that we are doing. Same way this fuel cell will take oxygen from outside, combine with the hydrogen, produce energy, and with water, byproduct water. So stable. And then supercapacitors, which can store charge much more faster, discharge faster. These things are becoming important nowadays. People talk about electric vehicle, where they will be required. Okay, quick charge, discharge, etc. Then of course the nanoscience, all these things are there. I think I better stop here because these things are not required. Yeah. Okay. I think I'll end here. Okay. That's enough. Before I just wind up, I just want you to tell, because your students, you are saying that if they ask what opportunity, etc. In basic science, central government established certain institutions called Indian Institute of Science, Education and Research. Okay. So if they are really interested in basic science, and not only that, IITs are also offering basic science courses. So this year onwards, chemistry also has, you will talk about more like this. So these kind of institutions are also available. Apart from the IITs, NITs you are familiar with, there are also these kind of institutions. ICERs, 7 of them are there. So you should also educate them about these central institutions and how to get them, etc. Basically, you have to get through some entrance examination. And you are asking him about mugging up, they will not qualify. If you do mugging up, you cannot qualify in any of these exams. Okay, that's the thing. So tell them that if you really want to get through. So thank you for patiently listening to me. I'll stop here.
Thank you, sir, for the excellent presentation and valuable insight shared with us. We shall now break for tea and refreshments. Participants are kindly requested to reassemble within few minutes for the next session.